Okay, so now we're looking at Unit 4, two variable data analysis. Unit 3 was more one variable. So this unit is looking at now two variables. So we have a couple definitions here you should read over and make sure you understand. A scatter plot is a graphical method that shows the relationship trend between two variables. Independent variable values are arbitrarily chosen and usually on the x-axis. In Unit 3, when you dealt with one variable data, there was a definite independent and dependent variable. When you're looking at the two variable data, they both vary. So there are situations where one can depend on the other more so than the other, but it can also work vice versa. The dependent variable values depend on the independent variable. So usually on the y-axis, usually goes on the y-axis there, like we traditionally did. And a reminder, x-axis, pen working. That's your x, that's your y. The trend is a pattern that occurs over time. So you usually look at a set of data, you can look at a graph, what's happening over time with the data you have that you're looking at. Line of best fit is a straight line graph that best represents the set of data. Correlation, the apparent relation between two variables. This is usually defined by the letter R. Okay, so that's correlation. And when we describe correlation, we usually talk about type and strength. So when I ask what type of correlation we have, you need to mention two words, basically the type and the strength. So types of correlation, if the line of best fit has a positive slope, it's a positive correlation. I use plus VE for positive, negative VE for negative. Positive is going upwards. Negative, think sad, down is going down. So if the line of best fit has a negative slope, it's a negative correlation. So the data is usually scattered, but you can see the overall trend, which we're going to talk about here in the strength. The strength of the correlation, if it's strong, you have a strong correlation, it's usually a very straight line. The trend is apparent but not strong. It could be a weak correlation. So we can see that they're related, but maybe the data points are not very close together, but you can see a trend going positive or negative. It's a weaker correlation. In the middle, medium, or moderate correlation, and if there's no trend, no correlation. A strong correlation, this would have, if I was say looking at an R value, we'll do this a bit later on, an R value would be close to 1. Okay, so if it's weak, you'd have an R value close to 0. And if you're looking at positive and negative correlations, you can have a +1 or a -1. Okay, or you can have a minus R value. You can have a negative R value. So it could be a positive R value. Can be positive or negative, depending on the type of correlation you're looking at. Okay, so classifying correlations. There's some examples here of what that looks like. If I look at the oval test, so it says recall the oval test from grade 9 to test for the strength of the correlation. Basically, you circle all the points as a group, and if it's an oval, that circle looks like an oval, you have a strong relationship. If the circle looks more like a circle as opposed to an oval, it's no or weak correlation. So depending on what the data looks like. So if I look at this data here and I draw a circle around it, that's a strong oval. I can tell that's an oval. It's going upwards. My slope is positive, so I have a strong positive correlation. Remember, type and strength. You must list both. If I circle this second data in B, again, that's a strong correlation because it looks very much like an oval, but it's going downwards, so it is strong, but it's negative. This last set, you can see it's very circular. There would be no correlation. If I look at the data below here, I can draw my oval. You can see the difference between the first one and this one. This is still looking like an oval versus the last one, which has no correlation. So I would still say this is a weak. You can say weak or moderate. And it's going up. I can see the trend is going up, so that's positive. If you looked at the last one we did with no correlation, you can't really tell if the data is going upwards in a positive fashion or downwards in a negative fashion. This one here again, that's still, I would look, it looks just like the one we just did before. So I still say it's a weak and it's going upwards, positive. And here, you could say this would say, I say it's a little more of an oval, not as wide of as an oval. So this I would say maybe a moderate. Negative, because it's going downwards. So medium or moderate. I think I said weak or moderate. Sorry, so first I should say weak, positive, and then moderate. Because you have strong, you have medium or moderate, and weak. Okay. So we have weak, and a moderate. So now let's look at drawing a median line. I might need a second here because I think I had issues drawing lines before in one of my previous lessons. Now, okay, there we go. Wow, I just had to swipe. Okay, so now we've got that figured out. So a median line, so we know what a line at best fit is, but a median line is a linear model used to fit a line to set of data. So similar to a line of best fit, but it's more accurate because we're using calculations to determine where the points are. A line of best fit, we looked at the data, followed the trend, and drew a line through the points to follow the trend. Didn't have to go through all the points, but it kind of followed the trend that happened. Here we have to do some calculations, and we have some steps here. So this is important to follow. We'll go through the steps as we do this example below. The median line. So the Environment Club is interested in the relationship between the number of canned drinks sold in the cafeteria and the number of cans that are recycled. The data they collected are listed below. So number of canned drinks, number of cans recycled. So first I'm going to, before I even follow the steps, I'm going to determine which variable is which. So do the number of canned drinks sold depend on number recycled? Or do the number of cans recycled depend on the number of cans sold? I would say the number of cans recycled depends on the number of cans sold. So I label them X and Y as such. The first step is to break the data up into 3 vertical sections. Each section should contain the same number of data points as close as possible. So sometimes if you have an uneven number, you can't break it into the groups you want. It's going to be tough to do that. So you can see that in this case. I'm going to break it up into 3 sections. So 3, the second section will have 2, and the last one will have 3. Okay, you could do 2, 3, 3, up to you, but we can't have 3 in each because we don't have enough data here. Next is to find the X median and the Y median of each section. So before I even do that, I'm going to plot these points. Remember that we need a title, so I'm going to say canned drinks versus canned drinked. Canned drinks sold versus cans recycled. Label your axis. So we have canned drinks sold. On my x-axis, my y-axis has cans recycled. going to go up by 2 because I don't have enough space here. 10, and the highest number is 36, so I'm going to go up by 2's here as well. I should say 30, it's hard to write. It's a bit smaller. Okay, and now I'm just going to go through and plot my points, and then I'll continue back to the median line. So 6 and 15, or where am I? 15 and 6. 18 and 2. I'm at 30 and 8, and I have another point here, 30 and 4, and 36 and 10. Okay, so that is my data here. So if I, let's go shapes here. If I draw my line of best fit, let's change my color. If I draw a line of best fit, it's going to go through to follow the trends. Doesn't have to go through the origin. I might place it around there. Oh, I don't want to do all that. 1 second. Got too much selected there. Let's draw this line again, sorry. I just thought it should be a bit lower. Let's put it about there. Oh, just lost my lesson. Okay, so that's my line of best fit. So you have to show your work for here. I'm going to do it on the side so you can see it here as I speak through the instructions. So line of best fit, I broke it up into 3 equal sections. Find the x median and y median for each section. So if I'm looking at delta 1, I have my x's are, I'm going to list them from least to greatest, 15, 18, and 23. My y's are 2, 4, and 6. So therefore, I have an odd number, so it's nice and easy. My delta y, my median here, is going to be 18 and 4. So I can draw that on my graph now. 18, 4. I'm going to draw it with a triangle and a 1, so you can see it's median 1. Median 2. This one only has 2 data sets, so I'm still going to list my x's. They are in order. And my y's. But you have to do a little more work here. So the x's I would have to add and then divide by 2. Same with the y's, which will give me delta 2. 25 plus 28 divided by 2 will give me 26.5. 1 plus 6 divided by 2 will give me 3.5. Okay, so you can see the difference there when I have an even versus odd number of points. So I can plot delta 2, 26.5, and 3.5. Okay, it's approximately there. And delta 3, my x's in order would be 30, 30, 36. And my y's would be 4 in order 8, 10. So my delta 3, my third median point here, is going to be 30 and 8. Which is actually on top of that point there. Okay, so we just found the medians for each section of the x's and the y's. Those give me those points to get my delta 1, 2, and 3, median 1, 2, and 3. I plot the medians using the triangles, that's delta. Use a ruler edge, and it's hard not to be able to use a ruler here, but I'm going to change my color. I don't have a ruler, so I'm going to do my best here to connect the first and the third median first and third median points. So that's done. And then, if the second point is not on a line, slide the ruler about 1/3 of the way toward the second point. Delta 2 is not on the line. So what you need to do is look at where delta 2 is. I like to draw a perpendicular line to it because then I can look along that line. I need to look at about 1/3. Okay, so I'm gonna see if I can. If I select well, let me just move that line. One second. It actually moves all my points. So I'm going to draw it a different color so you can see, and I'll write it out. The final one is in, let's make it green. Okay, so if I look at this line here, I have a perpendicular line to my median line. I'm going to break it up into thirds. And you want to keep the same slope now, and then draw the line where that is, which actually it kind of is where my line of best fit is, which doesn't always happen, but that's where it is. Okay, so median line. Okay, so those are your rules. It doesn't always work out so nicely like that, where it actually fell on the line of best fit, but we're lucky today. Describe any patterns that you observe in the graph and identify the type and strength of correlation. So you need to talk about both axes. So you want to talk about what's happening on the x, what's happening on the y. So we can look at the x's. So as canned drinks sold increases, so I'm describing what's happening on the x. I'm also going to describe what's happening on the y. What's happening on the y? The cans recycled increases. So I've just described it on both x and y. And then I'm going to talk about the type and strength of correlation. So I would say it's still an oval, and you can see it's positive, but it's more of a moderate. So I would say it's a moderate, and it's going upwards, so it's a moderate positive correlation. We drew the median line, you saw that. And then you're going to use that median line to determine how many cans will be found if recycling boxes, how many cans that will likely be found in the recycling box if 35 cans of drinks have sold. So if I extended this line, which I can't do without drawing a new one, let's extend this. I would say you can't have 8.5. So let's say approximately 9 cans found. Okay, So you're basically extrapolating, I'm extending to go outside of my line to figure out what that point would be. Okay, and that is Unit 4, Lesson 1.